Okay, so for the second video, I'm going to draw out the hemoglobin and oxygen dissociation curve. And so sometimes, so there's these three factors. It's, well, really four. There's pH, temperature, the concentration of DPG, and then the partial pressure of carbon dioxide that kind of affect the shift of this dissociation curve. So in general, it kind of looks like this. So you have your percent saturation of hemoglobin on this side, and that just kind of goes 0 to 100. And those are percents, obviously. And then over here, it also goes 0 to 100. And this is going to be your partial pressure of oxygen. So basically what this whole graph kind of relates is the percent saturation of hemoglobin of oxygen. So obviously you guys know that hemoglobin binds to oxygen. And so this graph kind of shows it's called the affinity of hemoglobin to oxygen. So basically how well can hemoglobin bind to oxygen and vice versa. So the graph kind of looks like this. Kind of has this like plateau part right here. So the numbers you need to know are when you're at 40, you're in the resting cell, and then when you are at 100, you're in the alveoli, or you're inside the lungs. So as long as you guys have that down, you should kind of be able to know these pressures and kind of what's going on with the percent saturation between hemoglobin and oxygen. So, okay, so 40, okay, over here we're in the cell. And then at 100, we're over here in the lungs. So this is kind of where you would be dropping off oxygen. And then this would be generally kind of where you're picking it up. So that kind of example that I have that would kind of be different in this situation is that for metabolically active tissues, so it would be like working or exercising muscles, these need additional oxygen at their cells. So the partial pressure of oxygen decreases because the hemoglobin will be able to let go of oxygen so that these metabolically active tissues can use their O2 preserves. So when you're at metabolically active tissues, the oxygen will be let go from hemoglobin so that they can get that oxygen to continue doing their metabolic actions. So like I said before, these specific factors that are going to affect these are going to be your pH, your temperature, your concentration of DPG, and then your partial pressure of CO2. So I don't know if you guys have ever seen this partial pressure of CO2 thing, but basically what this means is that it means the same thing as concentration, but because it's a gas, it has to be a partial pressure. So that's what PCO2 means, if you guys weren't aware of that. So basically, in general, when you have increased temperature, increased partial pressure of CO2, decreased pH, which can also mean increased acidity, this is going to shift your curve to the right. So this shifts your curve to the right. So all of these things are shifting right. So when you shift your curve to the right, that means there's decreased affinity of hemoglobin to oxygen. So that means it's going to be easier to let go of oxygen. And this makes sense because when you're moving right, you're closer to over here where you're in the alveoli. So that's where you're going to have the most oxygen. So then for your other set of these, your other factors are going to be decreased temp, decreased partial pressure of CO2, and then increased pH, which can also mean decreased acidity. So when you say decreased acidity, that actually means you're getting more basic. And when you're increasing acidity, obviously that means you're getting more acidic. So it kind of depends on how you feel like you want to memorize it, whether it makes sense to memorize it based off of pH, the number. So obviously if the number is getting bigger, you're getting more basic. But then if the number is decreasing, you're getting more acidic. So it's just kind of personal preference. So then this one is going to have you shift to the left. So when you're shifting to the left up here, that means that you are going to have increased affinity for oxygen. So then that means it's going to be easier to pick up oxygen. So this one right here, when you're shifting to the right, generally you can be able to let go of oxygen a little bit easier, and then when you're in the left, you can pick up oxygen easier. So then when you get into kind of more specific stuff, I'm going to go into the pH and then the concentration of DPG just a little bit more specifically. So when it has a shift in the pH, this is just an example that is in your book actually. When your muscle is at max exertion and max activity, so okay, you're in the thigh muscle, so this is doing activity. So like you're exercising or going on a run or whatever. So okay, you're in the muscle, and so when you're exerting it basically as hard as you possibly can, it's going to be doing anaerobic respiration. And if you guys remember anything about that, anaerobic respiration or metabolism is the same thing. If you remember anything about that, that means that you don't need a whole bunch of oxygen. So when you're doing anaerobic metabolism, that means you also are producing lactic acid. So obviously we notice it has the word acid in it. So if it has the word acid in it, that means that you are decreasing your pH or increasing your acidity. Making lactic acid, you're going to release more H+ ions. So this is releasing a bunch of H+ ions. I don't really actually know how many, but enough to change the blood pH is basically what you need to know. So you're releasing a bunch of H+, which means you're decreasing the pH, but you're increasing the acidity. So decreasing pH, increasing the acidity, which means that this whole thing is going to shift to the right. So then if we see that this is going to shift to the right, then that means that we are going to have, if it's shifting to the right, we're going to have a decrease. So shifting to the right means it's easier to let go of oxygen. So it shifts right, which means it's easier to let go of oxygen. So we kind of break this little bond right here, and the hemoglobin will let go of some of its O2. So the curve shifts right, it's letting go of oxygen. More oxygen is released into the tissues that are needed most for this anaerobic respiration. And even though it's doing anaerobic respiration, it doesn't need oxygen. It's so that your blood pH doesn't get super acidic. And this is called the Bohr effect. So then another factor that influences the shift of this graph up here is going to be your concentration of DPG. And these brackets right here just mean concentration. So when you have excessive or constant chronic hypoxia, which basically is just an extended period of time with low oxygen. So like when you climb up into a high altitude or something like that. So this chronic hypoxia causes you to make a bunch of DPG. So okay, we have hypoxia, which means you have an increase amount of DPG being made, and when you have an increased amount of DPG, this lowers the affinity of hemoglobin to bind to oxygen. So if it's lowering the affinity of oxygen, that means that it's going to be able to shift right. So it shifts right. So like if we go again up here, if we're shifting right, that means that you're going to let go of oxygen. So that will decrease your affinity for oxygen, and it's easier for oxygen to let go of hemoglobin. So then another thing that was on your quiz that I just think that you guys should remember, it was on your quiz this past Tuesday. You have to know that carbon dioxide and pH, these are the two important factors for determining kind of the stimulation of breathing. It's actually not the amount of oxygen. So these two right here. Alright, I hope that makes a little bit more sense for you guys.